Hi everyone, I'm Gordon, and this is the first video in a series where I'll be going end to end on a data science project, specifically focusing on a bike share system. And this is the page that you need to go to, the Kaggle page, to download the data that I'm working with if you want to follow along. And what kinds of things can we do with this data? What am I specifically going to be working on? Well, as you can see on this page here, we've got over 1.5 million trips made from one station to another recorded in this data set. And if we were working for this organization as analysts or data scientists, one question that they most likely would be interested in would be, how many negative experiences are occurring for customers in this system, and how can we help minimize those? And in real life, organizations do have to tackle this question. I know that some bike share systems have dealt with this by saying, well, we're going to do away with docking stations altogether, or in other instances, they will work on rebalancing, where they'll essentially drive from station to station with a truck and make sure that one station didn't get completely full, in which case nobody else would be able to drop bikes off there. Or maybe maybe the station is empty, so they go there to restock it with new bikes, etc. In either case, this is certainly a problem that we can get a better hold on by looking a little bit closer at the data and going from there. So that's what I'm going to be working on. And I'm working in Colab. If you're following along and you're working in Colab, I've got my CSV files already loaded in here. And I've already done a few things, but I will walk you through these just really briefly. You're going to want to go ahead and import pandas, NumPy, and the datetime module. You don't actually need random for right now. And later on, we'll be working with the Poisson distribution from SciPy Stats. You don't really need to import the standard scaler for pre-processing at this point. So once we read in the CSV files that we've got, we can take a quick look at what's located where. And in the stations file, we've got station ID as well as the total capacity for bikes at each station. We've also got a lot of information we don't need. In our journeys data set, we've got start journey and end journey information. And you're going to notice here, these are all in separate columns. We've got the day of the month itself, the year, hour, minute, everything in a separate column. We're going to work with that in a second to try and get something a little bit more useful. And it looks like each row here represents its own individual journey. So some pre-processing tasks to get started here. We're going to go ahead and perform a very simple merge to get all of our information in one data frame to work with. And we're going to be merging on start station ID. The next thing that we want to do, as I mentioned, everything is in its own column. We need to change that. We're going to try to get hour and minute into a single column. And we'll do that by saying, hey, pandas, go ahead and give us a new column, which contains both the hour and the minute. Because the minute is simply represented as an integer, we're going to need to go ahead and divide by 60. And what that's going to do for us is put together the hour and then the minute as a decimal trailing behind it. You'll see that in just a second here. We want to do that, by the way, for both start and end, if I didn't say that already. And you know what, let's pull it up really quickly so that you can actually see what does that code do right over here. Here's the end product of date time. Okay. And the next thing we need to do is we need to think about zooming out to a level that makes sense, because we've got minute, we've got times recorded all the way down to the minute. Really what we need to do is look at slices of time. So I'm going to go by the nearest hour here, and this is the code that we need to get there. Again, I'm just going to say, let's create a new column, and we're going to round the start date time column that we created a second ago. We're going to do the same thing for end date time. And this little lambda function down here, the only reason I'm doing this, it's more a matter of personal preference, but we're saying we want to go from the 0th hour to the 23rd hour rather than from 1 to 24. And again, same for end date time. And we can take a quick look at what this actually produces down here. And simple enough, we've got hour rounded to the nearest hour. And if you wanted to round this to the nearest half hour, there's a really simple way to do that as well. Here we're just going to say, okay, round it, but the object that we're asking it to round, we're saying multiply by 2, and then after we've done the rounding, divide by 2. And that's going to give us these half-hour slices of time. Personal preference, perhaps, but I am just going to stick with the hour-by-hour look at each station. All right. We also need to go ahead and map together date, month, and year. And the only reason we're really doing this, you'll see in a minute, is so that we can put together a group by function. And this code, once you run it here, you can see the start, day, month, year column and what's contained there. Right? Simple enough. And let's think about what we need from our data now. So we're almost done with the pre-processing steps. We want to be able to have a data frame at the end which tells us the mean average number of arrivals and the mean average number of departures for each station for every period of time that we're looking at, right? So for all 24 hours of the day. And to get there, we are going to need to execute a few group bys. And this first one here that I've got, this is just saying, okay, show me how many journeys took place at each station. And you can ignore the columns here, they're meaningless, but you can see for each station, we've got the total number of journeys that are recorded throughout any time of day. And okay, that's a starting point. We need to get a little bit fancier though. And as I'm doing this as well, I will just say the code that I'm using for this was provided to me by a classmate who put together the majority of the pre-processing steps. So shout out to her. I don't know if she wants me to say her name in this video, so I won't. Okay, I think I've done this correctly. So this first group by that we're looking at here isn't going to get us everything that we need, but it's going to prepare most of what we need, and we'll finish off the rest with another group by in just a second. And you're going to see once I execute this, it's going to look like a little bit of nonsense for right now. That's because it's not done. So we need to execute one more group by. In a second why we did each of these. Okay, almost done. Okay, let's see if this code works, and it does. Fantastic. Okay, so what did we do here? Let's go through this really quickly. The first group by that I showed you just really simply said, here's all of the journeys that took place for each station. And now what we're saying is, okay, we want to drill down a little further. So we're saying group by station ID, the rounded time, and the day, month, and year, and give us the counts for all of those. And then over here, we're saying, okay, let's take that same object that we just created, and we're going to perform a second group by on that in order to tell us what is the mean average number of journeys occurring across all days for each period of time, right? And we're gonna leave. We could round this to a whole number, but we don't need to. I'm rounding to the second decimal place because it's just easier on the eyes. But when you'll see it. I don't want to belabor the point, but you'll see in the next video when we're working with the Poisson distribution. What we are going to do here is say, okay, we know that this is the mean average number, for instance, at station 4, or excuse me, at station 1 during 4 a.m. We know that the mean average number of arrivals is 1.6. And what we'll do with that information is we'll say, okay, we're going to randomize or to model random arrivals at this station for that period of time. We're going to sample from the Poisson distribution where lambda is set to 1.6. The basis for that, if you're not familiar with the Poisson distribution, or if you're maybe a little bit unsure about any of the statistical grounding that we're using here, definitely encourage you to look that information up. But that is how we can model random arrivals. And I guess we also need to model random departures at each station. So I'm just going to tweak this slightly. And we need to, as we do this, remember the names that we've given each column. If we don't, we won't get what we're hoping for. So start rounded. Okay, fantastic. And we're calling this the departure data frame. Okay. And as I mentioned a second ago, we have to make sure that we are remembering the correct names. It looks like I may not have, but that's okay. That's easy to fix. And what we're going to go into the next video with here when we kick that off, we'll have two data frames that look like this. This one shows us arrivals. The next one is going to show us departures. We need to use the same code and get the names of the columns correct. All right, I'm going to go ahead and end this video right here since it's getting a little bit long at this point, and we'll kick off in the next one looking at what we can actually do with this data now that we have it into a usable form. Thanks for listening.